Well, hello once again. Our next notes are on what's called combinations. This is section 1-5 in your textbook. We're going to start with a couple functions here. So I just came up with a couple f of x and g of x. So why don't you jot those down? Once you've jotted those down, actually pause the video, jot those down, then come back to the video. So the first function, f of x equals 3x plus 7. Second one, g of x equals x squared plus 2x minus 5. Now, just a warning, sometimes people freak out about the F and G, and I could have used any letters there. F and G are used most common, but we could use any letters we wish. So what combinations are taking two functions, putting them together in some way. And the notation looks very difficult, but actually these problems are not too bad. I think we can all handle these. Let's find out here. Let's jump in. So first example, we need to find F plus G of X. Here's all that is saying. That's saying, let's add these functions together. So I'm going to add them. I'm going to keep things in order here. So let's just add these functions. We have an x squared term. We have 3x plus 2x, so that gives us 5x. And we have 7 plus minus 5, so that gives us plus 2. And that's it. And we can do the same thing for f minus g. Now we have to be careful here with the order. So f minus g of x, let's say we have no x squareds with our f function. We have this x squared here, so we're taking 0 minus 1. So we have a negative 1x squared. Then subtracting 3x minus 2x gives us plus x, 1x. Then we have 7 minus negative 5 is plus 12. So again, not too difficult. People make little mistakes with their positive and negative signs, but again, we can handle this. And if we go in a different order, we should be able to handle this too. So g minus f means take the second function, subtract the first. X squared minus, hey, there's no x squared, so that's going to be x squared. 2x minus 3x is minus 1x. And negative 5 minus 7 is minus 12. Now you may look at that and say, is this a coincidence? We have the same terms, some positive, some negative. No, that's not a coincidence. That's something that you'll always see when you subtract your functions in different ways. All right, next combination, f. Now this is sometimes read f of g of x, or you can say f times g, but actually it's more common to say f of g of x. Or excuse me, I'm thinking ahead of myself. This is f times g. Scratch that. Go back to that f times g of x. You'll see on the next page the next function I was talking about. So I apologize for that. F times g of x. But that means we need to multiply these two functions. I'll do the work up here. So f of x looks like so. G of x looks like so. Now once you write this out, you should recognize this. Oh, we're going to need to use the distributive property. Multiply every term of the first binomial by every term of the second trinomial. So let me do that. So if I do that, we get 3x squared, or excuse me, 3x to the third, 3x cubed, plus 6x squared minus 15x. There's your first term multiplied by all three of these, plus multiplying the 7 by everything gives us 7x squared plus 14x minus 35. And you will notice there are some like terms that can be combined, so we should do that as well. So that gives us a final function of 3x cubed plus 13x squared minus 1x minus 35. Okay, there's one last combination on this page we're going to talk about. That is g divided by f of x. Let's just write that out. So that's going to be equal to the g function, which is x squared plus 2x minus 5, divided by the f function, which is 3x plus 7. Now, unless you can simplify this, this is as far as we can go. Here's a mistake people make. People start crossing off x's and 3's and 7's. If you can't factor what's on top and bottom here, you can't simplify. So leave it like this. We're done. Now, there is one thing that we have to look out for, though. See this function on the bottom? If that ever equals 0, this entire thing can't be a function. We know we can't divide by 0. So we have to say, hey, what's on the bottom cannot equal 0. So I'm just going to go over here and do some work. I'm going to say, hey, what if what was down here was equal to 0? If you solve that for x, you'd get an x value of -7/3. So we have to include that in this function as well. We have to say, here's your function. However, x cannot equal -7/3. Okay, let's look at some other combinations. Now, remember on the last slide I talked about f of g of x. I was thinking ahead. That's what these are. So f of x, g of x, don't write these down again. It's the same functions. This is read f of g of x, and the second one is g of f of x. These are two different functions, so careful, don't confuse the two. Sometimes you'll see these written as f with a kind of, it looks like a little o, f of g of x. I prefer to write it in this original format. A lot of times your book will write it in this other format. It means the same thing. Here's what it really means. It means take, kind of like if we had, I'll put an example here. If you had f of 5, what you would do is you would take 5 and plug it into that function up there. So we'd plug 5 in this spot. Now I'm going to get rid of this idea because we're not plugging 5 in that spot, but instead what we're doing is very similar to that. We're plugging this entire function g of x, so right here, into this spot right here. So instead of writing down 3x plus 7, I'm going to say 3 times all this stuff plus 7. So you're taking this entire works, plugging it into the f function. So it is the f function with all this stuff plugged in. So let's simplify that. So we know we're going to need to distribute. So that's going to give us 3x squared plus 6x minus 15, and then don't forget that plus 7. The mistakes people make on these problems are little things like forgetting the plus 7 and forgetting this last step to combine like terms. I'm going to write it up here, 3x squared plus 6x minus 8. Now, second problem, likewise, same thing, g of f of x. That means we're taking this entire f function, plugging it into the g function. So I'm going to take this entire works here, plug it in for x. Hey, we have 2 spots to plug it in, but we can handle that. So instead of writing x squared plus 2x minus 5, I'm going to write all this stuff here squared plus 2 times all this stuff minus 5. A little bit more work to do to simplify this. First, now do not ever distribute that squared. No, 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 no. Squared means times itself. So I'll write this out twice. Then we can distribute. If you ever see a squared taken back this way, don't do that. Is not okay. Not okay. So if we multiply that, we'll end up with 9x squared plus 21 plus another 21, so plus 42x plus 49. If we distribute some more, we get plus 6x plus 14, and then don't forget that minus 5. And then we've got some like terms we can combine. If we do that, we'll get 9x squared plus 48x, and let's see here, plus, I believe that's plus 58. Okay, so these are all the different combinations of functions. We can add, subtract, multiply, divide, and we can take these different combinations, f of g of x and g of f of x. You can also do f of x, and we can also expand these, so it's like f of g of f of x, which would just mean doing the same steps over and over. Those get pretty complex, but mathematically they're no more difficult than what we're doing here. Okay, let's take a look at a second example. So, second example, I'm asking you to try some of these out. At this point, I would recommend you pause the video and try these on your own. I'm going to jump in and do them right away. So we have a new f function, f of x equals x squared minus 5. A new g function, g of x equals 2x plus 9. Let's try these combinations out. Like I said, I'm going to jump in. but I recommend that you pause, try them out, and then come back. So f plus g of x, that means add these functions together. That gives me x squared plus 2x. Combining these gives me plus 4. This next one, f times g of x. I'm going to put this up here. That means we have, oh, and I should have written in the other order, but for multiplication, order does not matter. So I'm multiplying these two functions together. We can distribute to multiply. If we do that, we get 2x to the third power plus 9x squared minus 10x minus 45. No terms to combine. We are totally done. Next one, f of g of x. That means we're going to take g of x, plug it into this f function. So instead of writing x squared, I'm going to write all this stuff here squared minus 5. Squared means times itself, so I'm going to write this out again. We're going to distribute here once again. So that'll give us 4x squared plus 18x plus another 18x, so plus 36x plus 81. And don't forget the minus 5. If we combine, we get 4x squared plus 36x plus 76. Okay, last combination. We have g of f of x. So this means we're going to plug f of x into this g function. So instead of writing 2x plus 9, I'm going to write 2 times all this stuff. X squared minus 5 plus 9. Which if we distribute, we get 2x squared minus 10 plus 9. And if we simplify, we get our final answer of 2x squared minus 1. Okay, hopefully the answers you got agree with my answers. And let's move on to something a little different. So now, next problem, we're going to graph these functions. So we're graphing f of x, g of x, and f plus g of x. Now here's the nice thing about this. We know how to graph f of x. That's like y equals x squared. It's a parabola with vertex at the origin, opens upward. We can get some points in here if we choose. Make it a little more precise, and I'm going to connect those points and extend this. So my first function looks like this parabola. Parabola at the origin, opening upward. Second function here. Hey, the nice thing is we know how to graph this. This is like y equals x plus 2. This is the graph of a line. Y-intercept is 2, slope is 1. So I'm going to go up to 2. I'm going to go up 1 and right 1, get some points here. And I can connect those points and extend the line. Now, what we don't know how to do, we don't know how to graph this combination. So first of all, let's just write what this combination is. So f plus g of x is going to be equal to, if we add these together, x squared plus x plus 2. I don't know about you, but I do know that this is going to be a parabola opening upward. I know there's going to be some shifts going on, some transformations. I don't know exactly what's going to happen. You might say it's going to go up 2, but what's this plus x going to do here? Now at this point you could pull out your calculator, you could choose some x's, find some y's. We could actually do a number of different things here to graph this. Let me show you a shortcut way. Let me show you a way that actually it works for any kind of combinations of functions. Since we're simply adding these two functions that we know how to graph, let's just add those points, those y values. For example, notice when x is 0, the blue graph goes up 0, the green graph goes up 2. 0 plus 2 is 2, so my new graph is going to be up 2 as well. When x is 1, the blue graph goes up 1. The green graph goes up 3. Add those together, you get 4. So your new graph is going to go up 4 units. So what we're doing is we're adding the y values together to give us our new y value. When x is 2, the blue graph goes up 4. The green graph goes up 5. Add those together, we get 9. So there's going to be a new point here. When x is negative 1, the blue graph goes up 1. The green graph goes up 1. So 1 plus 1 is 2. There's going to be our new point. When x is -2, the blue graph goes up 4. The green graph goes up 0, so 4 plus 0 is going to be right here. And we can see here's going to be the points of this parabola. So kind of a nice, simple way to graph without knowing any sort of rules, without knowing anything about graphing parabolas. We're simply graphing two things we know. We're taking this parabola that we do know, this line that we do know, putting the y values together to give us this new graph. So if you had your calculator out, put it aside. Let's try one more example of this without the graphing calculator. Let's see what we can do on this final example. So example says we want to graph f of x. Okay, we can handle that. G of x. And then let's add these together. So to do that, let's get my blue out here. First function is a line. Y-intercept 1, 2, 3, 4, 5, 6 is -7. And the slope is up 3 and right 1. Now, as you're doing this on your own, there are some benefits to being very precise with these points and getting a lot of points because we know we're going to add these y values together. So even though I missed some of those points, my line's a little crooked, I have those exact points on my graph. There's my first function. Second function I'll graph in green. Y equals x squared plus 1. Well, I know that's a parabola. Shift it up 1 unit, so I'm going to start with that. From that vertex, we can go right 1, up 1, left 1, up 1. In fact, if you square some, let's see here, if I go right 2, from that point I go 1, 2, 3, 4. It's actually 5 total units up because of the plus 1. And if we go 3 right, that's like 9 up from that vertex. 3 left, that's 9 up from that vertex. And there's my second graph. Now I might even say, do we even have to connect the points? No, forget it, because for our final function, f plus g of x, I'm not even going to write down what this function is. I'm just going to say, let's go right to our graph. So first of all, if x is 0, the blue graph goes down 7, the green graph goes up 1. Put those together, we're going down 6. When x is 1, blue graph goes down 1, 2, 3, 4. Green graph goes up 2. So that's going to combine that, we get down 2. When x is 2, blue graph goes down 1. Green graph goes 1, 2, 3, 4, 5 up. So up 5, down 1 is going to be up 4. If I go to my next point, we're going up 2, then up 10. We're going to end up with a point off of our graph. So let's try some points to the left. If x is -1, the blue graph goes down 10. The green graph goes up 2. So combining that, we get down 8. I'd like a few more points over here, so I'm going to think one more point on the blue graph. If I go left 2, the green graph goes 1, 2, 3, 4, 5 up. The blue graph would go 13 down, so that's going to be 1, 2, 8 down is going to be my final result. And actually, we know if we add these, we'll get something with an x squared term. So we know it's going to be a parabola. Once we see some points repeat, we know these parabolas have this nice mirror image. So we could continue to get a few more points by using the points we already have. And here's going to be the graph, whoa, a little crooked there. Here's going to be the graph of this new function, this combination. Now, how is this beneficial? Well, let's say I gave you a problem where we had to graph something like this. Y equals x squared minus 5x plus 2. We know this is a parabola opening upward, but we don't know much else. However, we do know how to graph this. We also know how to graph this. If we graph both of these and add the y values together, if we put these together, we will get the graph of that original function. So without knowing any special rules about graphing parabolas, you know your basic parabola with a vertex at the origin. We know how to graph any line. Add those y values together, we will get this graph of this function. Okay, so there's your basics. As you know, you've got an assignment to practice some of these. So once you practice these, you can tackle the next set of notes.